So thank you very much for attending WCFC in Japan in this time. So I'm Abe from Weather News Private Sector. So in Japan, we are continuously working on initiative to minimize disaster damage using meteorological services with public sectors, and private sectors, and academia all together. So with this disaster becoming increasingly severe worldwide, I hope we can go beyond the sectors and national borders, and so to make a opinion exchanges in this time, how to address this to mitigate and reduce the disaster. This is our topics today. And so to begin, I'd like to ask the representative provide materials, presentation materials for 5 minutes. So please kindly keep these 5 minutes. Thank you very much. So starting from Indonesia.
Okay.
So this is how to say for the controller.
So please, yes. Hello everyone. My name is Yoshua de Nugroho. You can call me Yoshua. I'm a project management officer. I'm also a meteorologist by training and by nature. I'm also doing some multidisciplinary research. So I'm combining social science with meteorological related science to produce new products for Indonesian society. I've been doing some kind of like 2 years, these 2 years, the recent 2 years, implementing some kind of project about the technological transfer related to improvements for our services. It may include AI inside. Okay, so yeah, let's get started. Okay, let me begin with the scale of the challenge. You know, this is the Indonesia's hydrometeorological risk landscape. If I want to say to you, it's located under 2 oceans, big oceans, and also 2 big continents, Indian Ocean and Pacific Ocean, Australia and Asia. So we are located in the center of the equator with a lot of meteorological dynamics, with a lot of challenge. Vary by months, I would say. And also, we provide services for nearly 270 million people. It's the 4th largest in the world. We have 11,000 islands, 1.9 million kilometers square. It's like 5 times bigger than Japan. And also, most of the disasters that has happened in Indonesia is related to hydrometeorological hazard. So we have a lot of, it's home of a hydrogeological hazards, I would say, because we have more than 100 of active volcanoes. We also have a historical history of significant tsunami in the Pacific or from in Indian Ocean. In the recent like 2 decades, I guess, we got 3 significant tsunamis. The most famous one is the 2004. And also we have a tsunami in Sunda Strait, 2018. And also 2018 in the central Sulawesi. And the damage and the casualties are necessarily high. So talking about hydrometeorological hazards, we do have a lot of high frequency but low to moderate impact disasters. And also we have a low frequency but really high impact disaster. That's the gap, I guess. We're doing really fine and good in predicting the high frequency, low to moderate impact, but it's not, and the gap is at the low frequency and high impact hazards, like the recent tropical cyclone Senyar, to mention. So this is the data and facts I will give to you about give you a bigger picture about the dynamics of the hydrometeorological hazard in Indonesia. Disaster related to that, I got that from 16 years of data. We evaluated 43,000 total disasters were officially documented by the NDMA, and this is the total recorded disaster. It's like going like exponentially higher by the year, and it's dominated by floods and maybe extreme weather. But we get in 2023, we have the highest is the wildfire. It's related to the El Nino. And now the El Nino is coming back. So this kind of impacts is still unnecessarily high, I would say. And the warning is there. So maybe AI could help with this, but let's talk more about it. So this is our approach, our modalities, our baseline over the data that we collect every day across the countries. We have 179 observation stations. Also, we have 102 upper air stations, and also more than thousands of automatic weather stations. Also, 44 weather radars. And 61 lightning detectors. So yeah, we collect those data like daily, like every 5 minutes. You can see how much we compute all those, and to formulate that into one single communication channel. So in the next 5 or 8 years, I would say there will be a time that most of the our observation channel will be obsolete, because most of them has been established since 2006, I would say. So there will be some of our radars or our automatic weather station will be obsolete. So that's a kind of a challenge for us, I guess, to maybe replace in this economy like that, in all the geopolitical dynamics and funding cuts and etc. There will be time that there will be no more observations, new observation devices. I don't know, but yeah, let's see. After we know Indonesia in how we deliver the services, we got this value chain of early warning from the global observation. We all know that. The exchange of international observation. We're also developing our own NWP, but it's still not in the operational phase. It's still in the research phase. Also, we just procured a new data center in the mid of 2025. I will talk about that after this. And yeah, from observation to the decision-making and action. I would say the one that is in the red rectangle, I would propose a new concept. It's not last mile activities. It's the first mile, because we have to put people first. So yeah, that's a kind of my proposed concept. I'll talk about that later. So this is our current project in developing our own products related to AI. We mainly focus first in the radar data refining and also the modeling. So it's still in the first year. So we will be developing this in the next 3 years. We start from Java. Java is the most populated islands in Indonesia and has the highest vulnerability, I would say, and also exposure. And talking about multi-hazard, we have volcanoes, and we have like heavy rain, and if it combined, there will be a lava mud flow, and there is no such. It's a high impact but really low frequency. But once it happens, there will be really like unnecessary high of number of casualties. So we're trying to use our approach first in the rain rate of the observed in the radar, so to provide better data. Also, we have our new data center that have 3 petaflops of capacity, and also the first one that we also deploy a GPU inside it, so we can run our AI model independently. So we really encourage in-house development because we don't rely on the external fundings or external subscription. So yeah, we're still open to all of that kind of things, but in this recent dynamics of the geopolitical dynamics and funding dynamics all over the world, we want to make it more sustainable, and we want to be independent in giving services to our people. So this is one of our co-development of the tropical cyclone with WNI. So we can see there is a significant benefits of using AI. We're comparing AI models with the conventional one. The difference is it has lower error of cyclone tracks. So maybe if we want to talk more about study cases, maybe our college from the university, from Indonesian University, will talk about it later in the afternoon. But yeah, we see there is a progress in detecting hazard. But I would say, like previous presentation said, that we would highlight that the human dimension is really important, because when you talk about disaster, it's not an event; it's a social construction. So why we put people in the last mile? People should be in the first mile. So this one of the concepts that we, Indonesia think that it is really important to bring up to this conference, because yeah, we have to realize that we have to put people first. It doesn't mean that we don't need AI, but we have to like recalibrate how we see the development. Is it in the growing in the good way or not? So also in the decision making from the forecaster itself, it's not always straightforward. It includes human judgment. It's really important. So AI in this case should be not replacing human, but AI should provide better tools and smart and faster decision support for meteorologists, our meteorologists, and for the people. And yeah, this one, the concept that I will propose to this conference. So we should take this first mile approach for disaster risk reduction. Thank you.
So thank you very much. So thank you very much for mentioning our collaboration with AI. And so in Indonesia, so many flooding issues have happened in the last year. So I'm to develop the new latest forecast. That's one of the I'm very much that's a so excellent development. I understand. Thank you very much for your presentation. So next, can we have your presentation for 5 minutes?
Okay. Thank you. I will try to be on time. Good afternoon, everyone. And I would like to thank organizers for this opportunity, and very happy to be here in this room and online, where there is we can see the collaboration between academia, government, and also the private organization working for the community. Thank you once again. Okay, so I will be talking about the application, how we are doing on artificial intelligence in weather and climate services in Nepal, and some of the challenges. We are on very early stage in this aspect. So I'll be talking about the context and the overview, why artificial intelligence and automated numerical emulators represent an urgent operational frontier for weather and climate prediction. with complex mountain terrain where the running weather models and also doing forecasts is very challenging job. And briefly talk about some pilot projects and progress that we are doing and the opportunities and gaps and way ahead. So why AI or machine learning for weather and climate services? AI is a very hot topic. It has a big potential for improving weather and climate forecasts, which will be ultimately helpful for the early warning for all. So it has a global revolution that the rapidly redefining the global meteorological models, introducing sub-kilometer spatial resolution and unmasked computing optimization. Recent DHM in Nepal, we have recently modernized our weather observation systems where we have more than 400 automatic weather stations, 3 radars, satellite information, and also lightning network, radioson, and this is a huge amount of data that our meteorologist has to analyze every day. There's a high demand of weather and climate services currently in Nepal. So the integration of AI and machine learning with the weather model outputs, post-processing, and looking into observational data will enhance or help us to meet this demand. And we have a very topographical challenge. Across 200 kilometers, we have more than 8,000 meters of diverse topography. And so it will help whether it is gridded data from weather models or from the observation. I think the AI will be the tool, could be the tool. And also for harmonization of weather models, data-driven neural networks directly complement traditional numerical weather prediction, where in the morning the potential has been presented in the morning session here also. And finally, for the disaster risk reduction and early warning for all, the enhanced lead time are vital to safeguard our local population from specialized hazards, flash flood, mountain convective, lightning, cloudburst, thunderstorms, and cascading effects of those hazards in mountain terrain in Nepal. And so AI could be the tool which can ultimately catalyze the information or increase the lead time for anticipatory action. So while we recognize AI has a big potential in future, but we also think that there needs to be scientific and ethical part here while we use AI. For that, we need to have proper policy. And so we have just recently passed our official hydrology and meteorology policy in 2024. And at that time, we did not have this AI specifically mentioned in our policy, but it has a policy strategy that says about enhancing the cutting edge, using cutting edge technology. But in 2025, there was a national AI policy approved in 2025 in Nepal, and which talks about using the digitalization of public service, having instituted strictly national parameters defining operational data security, automated service safety boundaries, localized server hosting guidelines, and also the algorithmic validation of the rules. And so now we need to work on our policy that would also amend our policy that would also match with our national policy. And some of the pilot projects, we had a private company which came to us, wanted to collaborate with us using the DHM data. It was in 2024. They they used our trend forecast data observation from METAR in the Tribhuvan University International Airport, and they look into whether that can be done or not in various parameters. And they showed a very good result in the temperature, but in other parameters it was not that good, but only they use, we were able to provide only 3 historical years. At that time, we were skeptical about working with a private company. And so it was just a test. And so main bottleneck was the lack of data to do such kind of research. And also there was another research from UK funded project, which we were indirectly related, but it was for the Oxford landslide framework, which would be helpful for anticipatory actions to prevent landslide or reduce the landslide impacts in Nepal for 14-day lead time. And they also talk about the data quality, availability of the rainfall data for the landslide forecasting. And currently, with this new government, very much prioritizing the digitalization and a very efficient public service. We also have our own, this year we put the budget as Indonesian small pilot project. So we are also trying to work on that. And so that is why this workshop is very instrumental for us to participate. So we'll get some idea how we want to work on. So we have a budget for flood forecasting and weather forecasting. This year, maybe we will do some pilot. And also we are collaborating with ADB and Swiss Development Corporation, where we wanted to look into flood, snow forecast and river flow forecast using AI. Also we are doing MOU with WFP. We wanted to test the role or application of AI in weather modeling and climate services. And also from this year, we are trying to, we are working with private company where we wanted to automate some of our dissemination or change or translating the language into various local languages for the weather warning and flood warnings. So some of the opportunity that we see from 5 pillar perspective that we can use storm nowcasting using the AI, using the radar and weather observation information. We can accelerate the numerical processing processes using the AI. Also workflow automation using the AI. We are at very early stage. We haven't done that, but this is what we think we can do. Using AI model integration to improve, because we use a 3-day forecast. We only do the 3-day forecast currently, but we wanted to move to 7-day forecast, and it requires huge research and computing system. So if we can integrate AI in understanding some of the processes, that would be very helpful. And finally, there is a very much demand in the sectorial expansion. So we can use some of the AI intervention to develop the products for various sectors. And the primary challenge using AI, what we think is the scarcity of the data. Being very diverse country from the terrain perspective, 400 automated climate stations is not sufficient. So we have to, because of its huge diversity in microclimate, we have to increase the number of stations for have better results from the AI. We have limited research, specifically in Nepal. We have not many papers published in Himalayan monsoon, Himalayan the weather systems, climate systems, and how the mountains affect the weather systems. So with that gap, we have to think twice what the AI produce. So that is also another challenge. And also the compute and capacity development. We do not have experts who knows about AI in our department. However, we are trying to collaborate with engineering institutes and academia to fulfill this, and also working with sending our staff to WMO training in AI. And also the next thing is that to close the gap in the policy perspective as well. From the policy perspective, also we need to think about how do we have the policy to collaborate with academia and private sector, because we do not have currently now. What we think that we have to do is we have to increase the number of stations and improve the quality of the weather data. Introduce AI, integrate AI in weather and climate models to increase the efficiency. Next is the capacity development to train our staff on the use of AI. And finally, partnership. Build or expand the partnership with the private sector, regional and global national meteorological and hydrological agencies like GMA, IMD, etc. And also NGOs like we are doing with WFP, NGOs, and also the private sector. For this, we have to look from the policy aspect, then it will be helpful to implement or work with the private agencies as well. Thank you.
Thanks. Thank you very much. So digital transformation in DHM is very much important strategy, I understand, with AI. And so aviation or some of the collaboration we are doing with academia and the private sectors, that's all good to hear. Thank you very much. So next, we would like to have presentation from Pakistan. So, hello, can you hear me?
Yes.
Hi, Muhammad-san. So would you provide your presentation, please?
Yeah, I already have provided.
Yes.
I sent through email. Did you not get my presentation?
Okay, just a moment. こっちから共有できます? Can you see your presentation?
Yeah.
Okay. Would you start your presentation? Okay.
We have two presentations from Pakistan Meteorological Department. I will be focusing on flood forecasting system in Pakistan and sharing a case study of 2025 flood. And the weather forecasting system will be shared by my colleague, Mr. Irfan. Could you please move forward? Yes, before going to details in flood forecasting, let's discuss about the catchment areas of rivers in Pakistan. Here you see the catchment areas of all 5 major rivers from east, Satluj, Chenab, Ravi, Jhelum and Indus. These catchment areas mostly lie outside our Pakistan boundary. Mostly the catchment area of Satluj is expanding towards Nepal, and mostly these catchments lie in Indian side. All is the mountainous terrain from where the discharge very abruptly comes to us. And if on the eastern rivers, Satluj, Ravi and Chenab, on Indian side, they have built dams, and sometimes releases from dam along with the rainfall are accumulated, which happened last year, and we suffered a lot, huge flooding in the eastern rivers. And for the catchment, some part lies in Afghanistan as well. that is for Kabul River, that is tributary of a major Indus River, and this sometimes also cause the problem when some westerly weather systems are approaching our region. Another area of threat is the mountain ranges in the central parts of the country, which are DG Khan Hill torrents. These are the not so high mountains as in the north sector, but these mountains are of medium height. But sometimes due to orographic effects, flash flooding is experienced, and due to steep slope, much damages are experienced over this region due to flash flooding in the hill torrents of DG Khan and Rajanpur in the central parts of the country. Yeah. Could you please move forward? Yeah. If we discuss about the last year flood event, it was emerged as a low pressure system in Bay of Bengal on 18th August. Then we issued first highlighted that this system has the potential to move in our region and to feed the moisture so that heavy rainfalls can be experienced in Pakistan. Yes, please move forward. This system moved in the northwest direction, and on 24th August, on 18th August, it was developed in Bay of Bengal, and on from 18th onward, we continuously mentioned this about this system in our bulletins. And from 24th, we issued warning for our eastern rivers, especially first warning for Satluj River, easternmost river in our territory. Then for on 26th, the third bulletin was issued in which we highlighted that this system has the potential to generate extremely heavy flows in the other two rivers as well, that are the Satluj and Ravi, that emerged as a very high intensity system and generated flows of exceptionally high intensity in all three rivers in the eastern side. That caused a lot of havoc. It was our information and the activation of relief and evacuation activities by PDMAs that we did not get any life loss in the region, especially in the northeast part of Punjab, due to timely evacuation of people, but a lot of damages were happened to animals, cattle, because a lot of dairy farms are in this region, and those animals could not be evacuated. However, all the human beings, all human population was evacuated. That is why we did not get any human loss in this region. Next. Please move on. Yes. This is the schematic diagram which tells us the how much time from one rim station to other rim station will flood peak take. But during last year, the intensity of this system was so high that in Chenab River, it takes almost double the time it was normally decided. It takes double of that time to reach from one point to another point. One reason for that was that during last, I think 14 to 16 years, there was no flood in these rivers, especially in the Ravi River, due to construction of dams in the upstream side by Indian government. We did not get any significant flow, but last year we get extremely heavy flows, and those flows did not follow this timeline. Almost double the time they took from one rim station to the other discharge mating station. That was a new phenomena which was emerged and observed last year. Maybe it was due to lot of infrastructure development in the river catchments and modifications in the river catchments, but we experienced that we were waiting for the water flood peak to reach the downstream near to Lahore Shadra station, but it took 2 days extra from the normal time. Yeah, please move forward. These are the flood peaks that we observed last year in the river Chenab. This was the river which we experienced maximum flows. 9 lakh more than 9 lakh cubic wave was initially observed. Then secondary wave was cascading system initially from 26th to 30th August. Then from 1st to 3rd September, 2 waves were observed. First wave was very high intensity, while the second wave was not of much intensity, but it was lower. But as the first wave was passing, while we received second wave, and all 3 rivers were flowing in the exceptionally high flood levels. Due to that, the accumulation of those flood peaks, the water could not be discharged in the Indus River so easily. It caused a lot of inundation, and in the downstream central parts of the country, southern parts of Punjab, there was a lot of breaches, and water penetrated into the population, and some motorways were also eroded due to those uncontrolled water flows. This is the situation for Chenab River. Please move forward for the other river. Yeah, these are the flood waves passing through different rim stations. Now we come to Ravi River. The first station is Jesser. In the upstream side, when water enters into Pakistani territory, it is first received at Jesser, then at Ravi Siphon, then it's received at Shadra, which is very close to Lahore station. And some of the areas of Lahore got inundated last year due to this exceptionally high flow which was received at Shadra. We are lucky that it was lower than the designed capacity of Shadra discharging station, but if it was 10 to 15,000 cubics more, then it may cross the discharging capacity of Shadra bridge. Then it moves to Balloki and Sadnai, and then it joined the Indus River. Next is, please move forward. Satluj River. This is the extreme eastern river which got the historical flow last year. But during this extreme flow of 385,000 cubics, its discharge meeting gauge was eroded in the water due to excessive flows, and we experienced a lot of inundation in this area in the upstream side, while on the downstream side, upstream station is Ganda Singh Wala, we experienced 385,000 cubics of water, but around the downstream stations, this water was expanded in the upstream areas, while we get very few low flood peaks in the Suleimanki and Islam headworks. These are the downstream stations on this river. This water, along with the Ravi and Chenab water, confluenced at the Satluj point, at the confluence point of all 3 rivers, and caused a lot of inundation in those areas. Next, please. Indus was continuously flowing above than 20% above than normal flows due to high temperature in the mountain areas. But on this river we had a major dam, Tarbela Dam. That was the reason why we stored excessive water and regulated this to avoid the confluence of flood peaks in the Western River, Indus River, and in the Eastern River. So this water was not having so much problem. It passed very calm and without any damages to any infrastructure and without any confluence with the water coming from the eastern rivers. Though the amounts of discharge were much higher side, but they were in the carrying capacity of the river, so they did not cause any havoc for the infrastructure and population over the Indus catchment and Indus river banks areas. Neither it caused, and there were some rumors and some non-professionals, they calculated that 14 lakh cusics of water will flow through in Guddu and Sakkar barrages. But those calculations, we did not certify those, and we predict that 6 to 7 lakh thousand cusics will pass only from those catchments. That is why there was no damage, and the havoc created in public of South Punjab province and Sindh province, that was also normalized. There was no situation of any disaster type in Sindh province or in the southern parts of the country. Next, please. Normally, we issue 3 types of bulletins. All these bulletins were issued. First is Bulletin A, that contains the hydrometeorological position of system, how much the potential is carried by a system for rainfall, meteorological features, what are the moisture sources which are fed to this system, and how much rainfall this system will generate, and the observed rainfall during the last 24 hours, if we have any, that's also mentioned in this bulletin, and extended weather outlook for next 24 hours, 48 hours, and 72 hours is included in this bulletin. This is qualitative bulletin which mentions on the quality of forecast or the potential of rainfall amounts, not quantitatively. While bulletin B, it's quantitative bulletin that mentions the reservoir positions, how much cushion is more available with the reservoirs to store more water, and what is the upper catchment areas forecast, how much water we will more be getting for the in the rivers, and to manage that water in the lower catchment, where this water will be flowing in the lower catchment sites, what will be the conditions in the lower catchments, whether there will be raining also or there will be dry weather, and river discharge is also included in this bulletin. What will be the trend of this river discharges? Either they will be increasing, decreasing, or remaining the same. And for next 4 hours, what would be the discharges passing through a specific point? All these and bulletin C is also containing the weekly weather outlook for specific catchments, and it includes the outlook for next 7 days. And this is the dissemination system. When we generate these bulletins are shared with all these organizations which are taking care of these disaster management work in the fields. I think there is no need for further explanation. Please move forward. Please move forward. Yeah, I think now my colleague will inform about the weather forecasting system in Pakistan. This is all for flood forecasting system in Pakistan, and I shared the last year flood story with you as well. Thank you.
Thank you very much. So I was surprised. Peak of hydrograph was so sharp in the flood event in some river. So an operation for quantitative flood forecast and early warning. So it's very much advanced. Thank you very much for your information. And So we'd like to have one more presentation from Pakistan.
Good morning, and from here in Pakistan, and good afternoon, I think, in Japan. I have already shared my presentation, and please share a presentation from your side.
Okay, just a moment.
Yeah.
Can you see your slides?
Yes.
Okay,
Thank you.
Would you start?
Okay. Yes. I am Mohammad Irfan Virk, and looking after the National Weather Forecasting Center in PMD. Next. This is a sequence of my presentation. I will discuss the forecast types that are being issued from PMD and what is the forecast, the mechanism we followed. And then we disseminate the weather forecast. And I also discuss the event during the monsoon 2025 that impacted our area a lot. Next. These are the weather forecast types. Basically, we are issuing the nowcast. This is very short range, very short range forecast, which is 3 to 4 hours. This is issued on our mobile app. We have the mobile app, and from there we issue the notification for a particular area that is disseminated to the community and all the stakeholders at that area. Then we issue the 12-hour forecast. Then we issue for 3 days forecast, and the medium range forecast is issued at time scale of 1 week or 10 days. Then we are also provide the forecast on request. If any stakeholders or anybody need forecast, we also give them the forecast on request. Then if there is a high impact weather and at the larger area in Pakistan, it can impact, there may be some heat waves, or there may some be flash floods or like this. Then we issued a press release or advisory at large. And this is disseminated all over Pakistan to all the stakeholders and to all the communities, and in electronic and also in social media. Next. This is the weather forecast system that we have. First of all, we have observational network in Pakistan. Take the and from satellite and from AWS stations from all over Pakistan and other stations. This data set is provided into our data system, and in our modeling, then the models are run, and we take the output from the models in our modeling center. Then from that, our forecasters analyze the outputs of that models and expert opinion. That finally they process the forecast to be disseminated. Next. This is the observational network all over Pakistan. Next. These are some of the products of our radars, satellites, and next. These are the models and the tools that we are being used here. We are using the output of WAF model, icon at 5 kilometer resolution, icon at 13 kilometer resolution, and JMA output also we are using, but it is force resolution, and GFS is a 25 kilometer resolution, and we are also taking the help of ECMWR. And when the data of these, we are also using the weather analysis visualization tool for the output of these models. For visualization, we are using MECAPS and SWAP model. And for satellite radar output, we are using the Jaybird software. Next. For weather forecasting, first of all, we check out, analyze the surface chart. This is the pressure lines. From here, we observe, analyze the system. Next. These are the some NWP products output. Next. After getting all these inputs, we analyze all the charts and outputs. All the forecasters sit together and they take the outputs of their models and other utilities and finally discuss for the forecast to be issued. Next. Monsoon 2025. During the monsoon 2025, we issued an impact weather which was generated basically in Pakistan, particularly during the monsoon season, when a low pressure area or depression, we say depression, is formed in the Bay of Bengal, and sometimes it enters in Pakistan and sometimes it dissipates in Indian side. When it enters in Pakistan, it is an extreme weather. So during the last monsoon season, we get at least 2 or 3 extreme weather events that hit in Pakistan, and they devastated many areas of Pakistan. Particularly, the first example is 17th July. In 17th July, low was entered into Pakistan that hit in Chikwal, where there was a rumors in the media that this is the cloud burst. Basically, it was a very intense system. When a low pressure enter into Pakistan, it downpours heavy precipitation, torrential rainfall. For that, we already issued a press release or advisory for this system, and it was followed by our daily forecast and our nowcast. Next. This previous one. Okay, this was an other system that hit in basically it was hit in the northeastern part of Pakistan, which is the catchment of our eastern rivers. As Mr. Aleem said that this was generated the flood in our rivers like Ravi, Chenab, and Satluj. Next. This is the nowcast which we issued in our local language in Urdu, and we disseminate on our mobile app. Next. It's okay from my side. Thank you.
So thank you very much. So you developed the numerical model in operation. And so one question. So is there any opportunity to utilize the AI model also?
Yeah. We are considering now we are lacking the AI modeling.
Okay.
Obviously, at present, it is much needed. And our researchers are trying our best to use the AI model. If there is any opportunity of AI modeling, we can develop the capacity of our researchers. It will be beneficial for us.
Thank you very much. So next, I'd like to have your presentation from TMD, Mr. Fatah.
Good afternoon. I'm Fatah from the TMD, and I coming with my colleague, Mr. Sompat. Educators, I will discuss about the AI in application in TMD and Works. And Thailand is here in the center of the Southeast Asia. This one is my workflow is like I have AWS and GS data, NWP data, radar data. My data about the 26 radar, and I have satellite almost. I use a satellite of the Fangyun of the China and the Himawari of the GMS, and working together. And we analysis about the climatologies, hydrologies, and big data, and analyze provide in the API. I provide almost data. I try to provide with like open data. I provide in API, in applications, in media such as network, radios, and analysis data, images data, and also the like ASCII data or the DECIDEF also in the AWP data. And in below is overlay agency. I have about the disaster management in the water management section. I have many departments that join together, and public health also. I have media in the radio media to sending data and cooperate with the Thai armies. This one is Thailand AWP. AWP of the Thailand have like a WRF model. The WRF model was base is the GFS and downscaling to the 3 kilometers with the data estimations. And on the right hand side is a web model about the web models. And this one I analysis about the list map from the AWP data and sets up about the warning if more than 200 millimeter per day have warnings about that in the graphic map. Okay. This one also I have cooperate with the WMO about the setting project FATFAT guidance system. FATFAT guidance system is like warning the FATFAT event. In the Southeast Asia is in fact is a setting with like MRC FFTS in from the 2009 and changed to the Southeast Asia FFTS in 2022. It's a collaboration between the Thailand, Laos, Cambodia, and Vietnam together. And this one, the FFTS like a warning the event. We need to testing with the event that in fact is event have or not. We need to try and alert for the calibrations. And after that, have a gap between satellite and soil because the base of the FTS is from the satellite, and the impact each event is different. This one is data from the FTS system. FTS system is to the AWP in product is left hand side is left for me here left left hand side is AWP data from the TMD, and also I use Vietnam AWP also in the right hand side of me. I'm not sure in the both. Also is FTS ingest this radar data that we share radar data about the Thailand, the Vietnam's, and Cambodia also is a joint radar data together. And this one, the data of the MRC product is like develop the automatic bulletin is support from the ADBC and NOAA also. Okay, this data, the radar data, TMD try to the open data is provide in ASCII data file with the radar composite that we developed together with the JMA, and after that we also the users nowcasting in I use optical flow and something like that. In the right hand side is optical flow. And now I working with the Met Malaysia to use the system that called length and the merge between the radar data and the AWP data together. And right hand side is district data that I forecast in like a nowcast is districts in Thailand. This one, okay, is a nowcasting is too. Okay, is a sub-district forecasting in a sub-district levels. And we try to use AI driven with the generate the warning in each area. Just this one. Okay. About after that, we develop the water level and monitoring dashboard, something like that. The pilot project, I have two basins in the Tapi Basin and Kolok Basin. Kolok Basin is like transborder river between Thailand and Malaysia is very important about that. And I not have more data in the Malaysian area. Yes, so I use the LSTM for analysis. This one I have radar data, landfall data, and state data, and analysis with the WRF data, and use LSTM for analysis. This one. And our challenge, radar TMD is almost have a noise. We need to use cluster removal. I have experience about the removal cluster. I try to use velocity to have if I have a hypothesis about the if not moving, that is like a cluster. But I some problem about the when we use in the highly mountain area, it have some problem because landfall mountain is not moved. So it's a skin also. It's some problem. I try to, in next step, I try to use this AI to analyze it also. And the nowcasting, now I backup merging together between optical 4 and AWP. In next step, we will plan to use CNN merge with LFTN also for the nowcast. And that's one is, I try to use application in only one application because it's like TMD have many division, and each division have applications. It's different. I try to combining together. Okay, thank you very much.
So thank you very much. So multi-source data integration, that's a challenging issue, I understood. Thank you very much. So now this is panel discussion time, but so 3 minutes, 4 minutes over. So we would like to have a more discussion in in the evening in reception time. So I think you audience have also many insight or opinion or comment. So we would like to have more cross discussion in reception time. So thank you very much for this time.
Thank you for managing and hosting all this.
Thank you from Pakistan and Vietnam from internet remotely. Thank you very much.